All right, so stats review number 3. The lengths in meters of cars normally distributed with a mean mu and a standard deviation of 0.714. The probability that a random chosen car is a length more than 3.2 meters and less than mu meters is 0.475. Find mu. So they're giving us a probability and they're asking us to find mu. So we're going to have to write an equation. And what we're going to do is we're probably going to be making a z value equal to a z value. So let's go ahead and put our information out here. All right, so let's write this in a way that makes sense. The length is less than mu, but it's also greater than 3.2. So the length is between mu and 3.2. So if I go and I graph that before it gets standardized, well, mu is going to be in the center. And then obviously 3.2 must be less than that. So we can go down this side here. And what we're talking about is this area between these dotted lines is 0.475. Okay, so what we're going to do now is we've got to take that 3.2 and we've got to change it into a z-score. Let's go ahead and take a look at what that looks like. So we use the formula 3.2 minus mu, and then we're going to divide by the standard deviation, which is 0.714. Now it's going to equal the z-score that corresponds with the 3.2 once it's been standardized, and that's what we have to figure out. So let's go ahead and create a symmetrical z on the other side. Now keep in mind that when we have it standardized, the mu is going to be 0, and then everything on one side will be negative and the other side on the right will be positive. So if I'm trying to find the area for the z-score, this positive z, it's everything to the left. And so there's a couple different ways to do it. I can add all this up. I also know that everything below the mean is going to be 0.5 of the area. If I take 0.475 and then add the 0.5 for the other below the mean, I find out that the area, everything below the positive z, is 0.975. Now, I can find that from my table. Now, that z is going to be the positive version of the z. I need the negative version. When I go to the table, I find out that that positive one is 1.96. But the other one's going to be negative 1.96. So now all I got to do is get the mu by itself. Multiply both sides by 0.714, and then subtract. Divide by negative 1, and you'll find out that the mean is going to be 4.599, or 4.6. Now, in number 2, the table summarizes the lengths in centimeters, and I've got 104 dragonflies. They want us to find the third quartile, the upper quartile. If we know there's 104 total dragonflies, we know that approximately 25% of it is above that quartile. So all we've got to do is multiply the 104 times 0.75. And then we're going to find out that's roughly going to be the 78th piece of data. And so if we add these up, I get 8 plus 25, that's 33, plus 28. I know that that 78th piece of data is going to be in this 5.5 through 7 category. And so that's all they really need to know, and that's all we're going to tell them. For part 2, they want us to draw a histogram. And so we got our graph paper here, and we've got to represent the data. Now you'll notice how the classes touch. They go from 3.5 to 3.5. That's good. So the other thing we've got to keep in mind is that we are going to be using frequency density if the class widths are different. And in the first class, you can see that it goes from 2 to 3.5. That's a class width of 1.5. And the next one is only going from 3.5 to 4.5. It's got a class width of 1. So obviously, all it takes is 1 to be different. So I've got to use frequency densities. And all I got to do is take 8 and divide it by 1.5, and 25 and divide it by 1, 28 divided by 1, 31 divided by 1.5, and then 12 divided by 2. And then I've got my frequency densities, okay? And so now I've got the information I need. Now keep in mind the lengths, they're going to be on my x-axis, and the frequency density is going to be on my y-axis. And so what you want to do is pick a number, take a look at the range of values. Our biggest number is going to be around 30. So we're just going to make a scale that goes up by even increments. And then along the base or the x-axis, we're also going to pick a scale. And you'll notice we're going from 2 to 9. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 along the bottom. And it's important that you make sure that you label both your axis. The y-axis is going to be frequency density. In this case, the x-axis is going to be length in centimeters. Anyway, we'll take our first class going from 2 to 3.5, and that's going to go up to a frequency density of 5.3. So we go to our graph here, and we locate 2, and then go to 3.5 and raise it. Again, it doesn't have to be exact. Obviously, we have to make it a little bit above 5. And then we go to the next one, and that's going to go 3.5 to 4.5, and that's going to go up to 25. So I lay that out, draw the bars, try to make it neat, but don't kill yourself. And I noticed some of you in class coloring these things. I wouldn't mess around with that. Anyway, the next one is going to go from 4.5 to 5.5, and that's going to be a 28. But again, don't, try to make it so it looks reasonable. And the next class is going to go from 5.5 to 7. And so then it's going to be about 20, a little bit above 20. And the next class is going to go from 7 to 9. And that's going to be 12. And so we put that there. Not the greatest. Okay, that's okay. And then, like I said, make sure that you label both your axes. All right? And that's pretty much all there is to it. Now, a couple things you've got to remember, that when you're doing a histogram, there can't be any gaps between the bars. We also got to make sure that if, in fact, there were gaps in our data, for example, had it gone from, I don't know, say it went from 2 to 3, and then 4 to 5, all right, and then 6 to 7 for our classes. We would have to add a 0.5 on each end. Right now, it looks like the class width is going to be 1, but really, it's going from 1.5 to 3.5, or 3.5 to 5.5. So if you don't put this adjustment on there, what will happen is your class widths will be the wrong width, and their frequency density will be all screwed up. Another thing to remember is if there's an open class means everything and up or everything and below. What you do is pick the next closest class. So for example, at the end, if it said from 9 and up, all right, well then what we would do is we would look at the class before it, and whatever size it is, we would double that. And then that would be the class width that we would use. So just a couple things to keep in mind. All right, number 3. The number 3, Jason throws 2 fair dice, each numbered 1 to 6. Event A is that one of the numbers obtained is divisible by 3, and the other number is not divisible by 3. Event B is the product of the 2 numbers obtained is even. All right, so keep in mind, it says we want to find out if they're independent. If probability of A times the probability of B is equal to the probability of A and B, well, then we know that these are independent. So what we've got to do is figure out the probability of A and the probability of B and the probability of A and B, and then check to see if when I multiply A times B, I get what I got when I got A and B. So anyway, how are we going to figure out the probabilities? Well, one way to do this is we got dice, and we know the possibilities. We got 1, 2, 3, 4, 5, and 6 for the one die. And then we've also got 1, 2, 3, 4, 5, and 6 for the other die. And in this case, you'll notice how they're talking about a product of the 2, and then the other one we can tell by just looking at the 2 dice. So we're going to put the products of the 2 in the middle here. And all we got to do is multiply the different combinations and fill that in on the table. And then once we've got that, what we're going to do is we're going to find out How many even ones are there? So the products are even. We circle those, and then we count them all up, and we figure out how many we have, and we divide it by 36. Oh, I'm sorry, event B is the even products. So if we take these, you'll find out that we've got 27 out of 36, so the probability is going to be 3/4 that it's even. Now, event A is actually finding out or rolling the two dice, having one of them divisible by 3, but only one of them. So now I go through and I mark this off, which ones meet that criteria. And, you know, obviously if a 3 and a 1, that works. A 3 and a 2, that works. A 3 and a 3 doesn't work because they're both divisible by 3. So anyway, I go through and I just mark off the possibilities here. A 6 and a 4, that would be good. And a 6 and a 5 would be good. 6 and 6, no good. When you count them up, 16 out of 36 or 4/9. Now, the probability of both, that means they meet both conditions. So what I'm looking for is the number of circles that have x's in them. That means that not only did they have an even product, but one of them was divisible by 3. And I count those up, and I find out that the probability of A and B both happening is going to be 12 out of 36 or 1/3. Now, all I got to do is find out if 3/4 times 4/9 equals 1/3. If it does, these guys are independent. If it doesn't, they aren't. And they are. Now, the next question for part 2, it asks about mutually exclusive. Well, if they're mutually exclusive, that means one can't happen. They can't happen together. One can't happen with the other. So, for example, I can't roll an odd and an even number, one or the other. So, in that case, the probability of A and B both happening would be 0. And since the probability of A and B both happening at 1/3, and that's not 0, these are not mutually exclusive. All right, for number 4, they've given us a tree diagram. They've given us some of the values, and then they also tell us that at the very end, the probability that a randomly chosen person views past photos fewer than 3 times is 0.801. Now, unlike other probability trees where you have to find the probabilities, they've given us a probability, and then we've got to go back and work it backwards. So in this situation, we would normally find the probability of fewer than 3 times and add these two probabilities together. And that would give us 0.801. All right, so now we've got to go backwards. We're going to find out what would have taken to make that happen. Well, we know that the 1 is x, so the other probability would be 1 minus x. And we know that if that's 0.76, this is 0.24. I can figure out these probabilities now. And then when I go backwards, well, imagine you're actually doing it. It will be x times 0.24 plus 1 minus x times 0.9. And when they add those together, I should get 0.801. So all I got to do now is simplify this and figure out what x is equal to. And when I do, I'm going to find out that if I combine like terms, I'm going to get what? Negative 0.66, and then a minus the 0.9. When we get this, we're going to get a 0.15 as a probability. So replace that. That's the answer to part 1. Now in part 2, they said given the person views past photos at least 3 times, find the probability this person takes at least 100 photos. Now keep in mind, this is a conditional probability. So if they want to find the probability that at least they view at least, or they take at least 100 photos, given that they view at least 3 times, well, all we got to do is find the probability of both of these things happening and divide by the probability of the given thing happening. So the probability of taking at least 100 photos, well, we know that's 0.85 times of at least 3 times, so that's going to be times 0.10. So that's the probability of both of them happening. Now, the probability of the given thing happening, we already know the probability of viewing fewer than 3 times. So the probability of viewing at least 3 times must be 1 minus that. All right, so all I'm going to do is take 0.85 times 0.10, divide by 1 minus 0.801, and I get the probability is 0.427.